Hey, everybody. Okay, today we're going to start talking about Galveston Bay ecosystems. We're going to touch on a little bit of history. This is the first part of a two-part series. So let's get started. So we're currently in this coastal environment portion. So if you're following along in the syllabus, you'll find this under that section. And from here, we're going to be talking about tidal habitats, wetland biogeochemistry, climate change, et cetera. So today, by the end of this presentation, actually by the end of part two, you should be able to identify key geological and hydrological features of the bay, major habitats in the bay system, and understand a little bit of the historical and current influence of us, anthropogenic influences within that ecosystem. Okay, so big picture. And again, this really should be reviewed. But when we're looking at biologic communities and the biosphere as a whole, we're talking typically about how things happen at the whole organismal level, and how they interact with the abiotic environment as well as with each other. But understand that why they do that, why you find them where they are, the specific adaptations that they have that allow them to be successful in fulfilling their ecologic niche, those can occur as low as the molecular level, right? Those of you who have good chemistry backgrounds know that atoms are almost predetermined how they fit together with other atoms to form molecules, right? And how those fit together to form compounds. So all of this kind of builds on what's happening at the atomic level and has done so through millions of years to form the level and complexity of living organisms that we see on the face of the earth today. Okay, so when we look at Galveston Bay as a whole, we're really talking about we're talking about the largest watershed for one single bay system in Texas. Now, this is not by far the largest watershed in the United States, or even globally. That record in the United States actually would fall to the Mississippi River Basin, which the watershed for the Mississippi River, where it exits there by New Orleans, that entire watershed covers about 1/3 of the entire continental United States. So much larger than what we have here for Galveston Bay. But the Galveston Bay watershed is still quite large and is the largest in Texas, extending far north of Dallas-Fort Worth. If you're familiar with Denton County, Denton, Texas, where UNT is located. So, over 650 square miles, 230 plus miles of shoreline. There are two major tributary systems in the bay. This includes the Trinity and San Jacinto rivers. But there are multiple subwatersheds because there are a variety of other small, influential like creeks and bayous and that kind of thing, especially when you get down close to the bay. And we'll talk a little bit more about that as we go. Much of the watershed, especially, let me get my laser pointer going here. So much of the watershed, especially if you look up here in this area, which we would refer to as the upper Galveston Bay watershed, much of this is coastal prairie, and there are a number of depressional wetlands in these areas. That's true of some of these orange areas here in the lower watershed as well. There are, especially in Brazoria County and over here in Chambers County, there's a lot of coastal prairie in those areas as well, and some remnant depressional wetlands. We're going to talk about prairie pothole wetlands as we move forward over the semester. One of the important things when we talk about anthropogenic or human-induced influences, nearly 1/2 of the Texas population as a whole lives in this watershed. right? So, you've got the two largest cities in Texas, and these cities actually rank among the top 10 in the United States. In fact, if my memory is correct, I think Houston is the number four largest city in the US. Dallas Fort Worth is somewhere in there. We've traded spots back and forth over the years with Dallas Fort Worth. So we're talking about a lot of people, and that means a lot of converted land in order to support roads and houses and agriculture and industry and all of these different things, right? So a lot of opportunity for us to influence what's happening in the biome as a whole, just through our actions. As I mentioned, these are, the bay is essentially divided into two segments. The upper watershed, and I'm sorry, I said the bay. The watershed, the bay's watershed is divided into two sections. So you've got the upper portion of the watershed, you have the lower portion of the watershed. The upper portion is by far the largest portion of the watershed. And how this was decided was based on really, it was based on the location of two major impoundments. And this would be Lake Livingston here and Lake Houston here. In fact, Lake Houston is where the city of Houston and actually Galveston and much of the surrounding area gets much of its municipal drinking water supply from. Lake Livingston, there is some water supply that comes there. There are starting, because the population in Houston is continuing to grow and this whole region is continuing to grow. There are more demands on surface water. We're going to talk about why those demands are so important relative to groundwater, which was historically more important. But there are starting to be referred to as interbasin transfers. This has been going on for, 20 years. Gosh, 15 plus years ago, I did some consulting work with the Houston Advanced Research Center on the Galveston Bay Freshwater Inflows Group. And at that time, we were looking at, closing my eyes to try to remember everything. So we were working on what was happening in terms of water flowing into Galveston Bay, because that freshwater influx into the bay has some importance as we're learning over the course of the next several weeks. That salinity gradient that occurs there is really important, but it's a major factor of that is how much water is flowing into the river, and demands on that fresh water, because we use surface water for so many things, is increasingly important. So they have been looking at transferring water from the Trinity water shed over to the San Jacinto watershed, because the Trinity is so much larger. So there's such a greater amount of water flow. All right, so as I pointed out, so here's Lake Livingston here. We've got Lake Houston down here. And again, there are a lot of little sub-watersheds in here. And these are primarily around those, a variety of smaller bayous and streams. So you've got Spring Creek, Cypress Creek, Clear Creek, Dickinson Bayou, among others. It was I'm sorry, that's the Trinity, but over here is the Double Bayou watershed. So there's a lot of these. Chocolate Bay, Chocolate Bayou feeds into Chocolate Bay, and that's an influence down here in the West Galveston Bay watershed. So the lower part of the bay, so this area below these two impoundments here, that's 4,000 square miles of drainage area from these two major reservoirs, reservoir and impoundment. So in impoundment, we're taking water, impounding it behind a dam, and so that forms these big reservoirs that are actually part of the river's meander area, really, in most instances. And so that's why oftentimes it's easy to recognize lakes, man-made lakes behind these impoundments, because they have these very odd shapes that follow depressions that are kind of part of the meander area of the river itself, inside of its higher banks. So about 6 million people residing in this portion of the watershed, and much of that is actually within the 5-county area right around Houston, Harris County being the largest county in Texas by population. Um, it also contains a lot of other things. So within this lower watershed, we have the fifth largest container port in the United States by tonnage, the 16th largest in the world. We have the largest U.S. petrochemical complex in the U. I'm sorry, it's the sixth largest U.S. petrochemical complex. I forget where we rank globally. For a long time, we were the seventh, I believe, seventh or eighth, but it's up there. And so when we talk about the influence that has on the ecologic communities in the Bay System, it's fairly significant, as we're going to unpack as we move through this. Okay, so when we talk about human history, humans had had an impact on Galveston Bay, at least dating back into the last ice age. So, the last ice age ended about 10,000 years ago, a little more than 10,000 years ago. But humans have utilized and occupied this area dating back at least 14,000 years ago. Um, there are a number of tribes that have inhabited the Galveston Bay area. Some of them were seasonal encampments, so they would kind of move in and out, especially during the Ice Age periods. Um, a lot of tribal communities were transient, so they were following their food and following seasons in order to find livable conditions, right? After the last ice age, when the ice pack started to recede, and the climate really has been very stable over that period of time. So about 10,000 years ago, the Earth's climate came out of that ice age and warmed and then steadied and kind of leveled off at a global average temperature of around 59 degrees Fahrenheit. And it's maintained right around that level since that time. And that really opened up opportunities for agriculture. You can plant food where you can predict what the rainfall is going to be, what the temperatures are going to be. You can take advantage of good fertile soil conditions in those areas based on the climate of that area. That really wasn't possible previously for a lot of factors. The climate had a big component in that because the climate was more fluctuant. So the first Europeans didn't really get to Galveston Bay until Cabeza de Vaca was stranded here in early 1500s. And that started a shift in terms of the European influence in the New World entirely. And Europeans, our footprint and the way we interact with the natural world was significantly different than the natives who lived here. As you've known, and I won't expound on this greatly. I'm not an expert in that area by any stretch. But we do have a lot of evidence. One of the things that's really interesting in this area, and I can tell you from my private practice, so anytime you're going to be doing any excavation for any reason, whatever that is, there are laws in place, federal and state laws that require surveys for antique or ancient human artifacts. And that includes things that might be as ancient as shell middens or areas where's my, here we go, here we go. So shell middens that are part of these Native American settlements. Sometimes they're associated with grave sites. They've been associated with living areas and that kind of thing. So, and there are quite a lot of them in this area. So anytime excavation is occurring in an area that hasn't previously been excavated, the Texas Historical Commission is involved in that, and the permitting processes clear to the federal level are very attuned to protecting these types of resources, mapping them and understanding them before any work proceeds in those areas, if it proceeds at all. Okay, so as time proceeded, you get move forward into the 16 and 1700s. There was much more European exploration and colonization. Turns out the New World was very rich in resources. Here in the Gulf Coast, Spanish governor of Louisiana. So, France and Spain and Great Britain established colonies here. They established ownership over these huge swaths of land through the United States. Um, so at that time, Spain owned much of the area around Louisiana, Texas, and others. So his name was Bernardo de Galvez, and he commissioned a survey of the entire Gulf Coast. And so you can see these maps here that were drawn depicting the Gulf Coast. And of course, these maps are not as accurate as what we're able to generate today, but you kind of get the sense they had a pretty good idea that what was happening here along the coast. So, as part of that, Galveston Island was mapped out and named after Bernardo de Galvez. So Galveston Island and Galveston Bay are both had that namesake. Moving forward, again, people kept coming, and these resources continued to be more and more important in terms of where people were settling. And there started to be, especially in the Galveston Bay area, a transition from the bay being a source of food provision, where fisheries were really important, agriculture was important, to, in terms of where people settled, to developing into really a port where we were transporting and trading goods in this area. And so as you move from the 1800s into the 1900s, there was a sharp increase in the whole volume of things that were being utilized from the bay system to the point of really being exploited, where they were being overutilized in some areas. We'll talk a little bit about oysters as we move forward. The first deep water channel was being dredged into Houston. Actually, that channel started during the Civil War and was just in the very upper part of the bay, kind of around the area where the Fred Hartman Bridge is, Morgan's Point, if you're familiar with that very upper part where the San Jacinto River empties into the upper part of the bay. In the late 1800s, Houston at that time was the largest city in Texas, as it is today. But at that time, it only had 22,000 people in it as opposed to nearly 4 million. Significant differences there. So I talked about the channel into the bay, and I want to touch on this a little bit more because as we start to look at anthropogenic impacts to bay resources and the ecologic communities there, the bay really on average is only about 8 feet deep, right? So in fact, it's actually much shallower in many areas. There are many areas of Galveston Bay, especially in West Bay, some of these areas up along the shorelines along Trinity Bay, where it is no higher than knee high on me, so no more than a couple of feet, and you can walk some distance out into the bay, where it might only be waist or chest high. However, the ship channel, currently, you can see the ship channel, not the chip channel, sorry, the ship channel is dredged all the way, inland here, clear to the Turning Basin in Pasadena, all the way down here, following this dotted line and out into the Gulf of Mexico. And it's currently dredged to about 45 feet on average. So typically they'll do what they call over dredging to account for backfilling from sediment deposition and that sort of stuff as water settles. So I think they actually dredge it to 47 feet, anticipating that that's going to fill in relatively quickly early on. I know there have been plans to both deepen and widen the ship channel to 47 feet, and I forget the width off the top of my head, but that is to accommodate ever increasingly large container vessels, in particular. The Panamax vessels are the ones I think they're trying to accommodate now. And so that depth, I think, is going to be, again, I should look this up before I shot this video, but I want to say it's about 65 feet, so about another 20 feet. So that's a significant difference from the 8-foot surrounding area there. So there are other small channels that come out. There are several along the backside of Galveston Island that go out into West Bay a little ways, but nothing of the magnitude that you'll see here. Okay, so one really big important event, obviously, Texas A&M Galveston being located on the island in an area that was very hard hit by the 1900 storm. This was you'll pardon what I'm going to say next, a watershed event. It really defined how we started to settle on the coast. From that time forward, I'm sorry, let me rephrase that. It really shifted the way we settled on the coast. It shifted where the biggest port was, right? Up until that time, the port of Galveston was really the port, right? That was really where things were coming in, and the things were moving from Galveston up to Houston and then out from there, mostly via rail or barge, some barge traffic as well. But after that, the port of Houston really took off, right? Because it was further inland, it was better protected from storms like this. There's a lot out there. Galveston has a rich history built around the 1900 storm. While you're on the Texas A&M Galveston campus, if you're not a permanent resident, I would really encourage you to get out and check out some of the museums and some of the things that are dedicated to this storm. This book, Isaac Storm, is a really interesting one and a good read. The One thing there are a lot of people here who still have roots that date back prior to that period. In fact, my wife's family from Italy moved to Galveston prior to the 1900 storm, and there were quite a few of them that survived that storm. In fact, we have a piece, it's in our office writing desk, that actually survived that storm as well, an old wood writing desk. So it still has an impact on people whose families were part of that history in Galveston. So take advantage to get out there and take a look at it. Like I say, it really shifted the way things developed on the coast in a very meaningful way. Well, so as I mentioned, the port, really the focus of port facility shifted from Galveston to Houston, and in the around the 1900 storm. And since that time, that port has really developed extensively. And because of that, a lot of other manufacturing facilities and other, residences, among other things, roadways, all developed in, kind of centered around that. And our pollution control technologies and our understanding of toxicity to humans and the environment was not as strong in the early 1900s. We're talking about 125 years ago. We just didn't have that understanding that we do today. And so pollution was, to a great extent, largely unchecked until we got well into the 1970s. And in some ways, it didn't even really start to change until the 1990s. So there was an opportunity for legacy pollutants really to build up in the environment in ways that we're still dealing with, here in the 2020s. So in the 1980s, movements really began to restore the health and natural resources of the Bay. Those were offshoots of things that occurred in the late 60s, early 1970s. Another really good book, I should put a copy of it up here on the screen on the cover, but Rachel Carson's Silent Spring. So Rachel Carson really was just a citizen that had a real interest in nature, birds and butterflies, and gardening, and that kind of stuff. And she really started to draw linkages through citizen science, just through observations about the prevalence of toxins in the environment, specifically DDT, which was used as an insecticide at that time pretty broadly. But there were a lot of other things that were part of the manufacturing megalith that was the offshoot of World War II. After the war ended, a lot of the manufacturing processes that were war dedicated then turned to manufacturing products for domestic use, and a lot of those things were based on technologies from that era. And so a lot of herbicides and pesticides that were used at that time were part of that manufacturing uh, effort. Um, so as we started to develop an understanding of the impacts that we were having in the 1970s, you started to see some real federal movement on that. And so that culminated in not only a large number of environmental laws as acts of Congress, so things like the Clean Water Act, the Toxic Substances Control Act, the Comprehensive Environmental Response, gosh, clean Environmental Response and Comprehensive Liabilities Act. That's what it was, CERCLA. TSCA was a really big one. There are others, RCRA, a variety of them. And then agencies that actually were in charge of applying and overseeing those regulations. So, like the EPA, the Fish and Wildlife Service with the Fish and Wildlife Service with the Endangered Species Act, those kinds of things. And then in the 1980s, 1990s, you started to see more effort by nonprofit organizations, citizen science organizations working in lockstep with state agencies that were by that point given authority to apply their own regulations in order to meet the requirements of the federal regulations. And we started to see really significant changes. So just for example, not herbicides, fertilizers and byproducts of things like soaps, so phosphorus in particular, but nitrogen. These things were very prevalent prior to the 1970s, and they had a lasting impact, especially in Upper Galveston Bay, because you had these huge watersheds through the Trinity and San Jacinto rivers, plus all of the manufacturing complexes in the Houston Ship Channel and the lower San Jacinto, that until the 1990s, we really didn't start to see any movement. And actually, some of that movement in the 1990s is when they went back and strengthened things like the Clean Water Act. So that was really important in terms of having significant impacts on the Bay system. I have a colleague and actually a prior instructor who I took graduate level courses from, Jim Lester. He's now retired, was executive director for the Environmental Institute of Houston, Center at the University of Houston Clear Lake, went on to be president of the Houston Advanced Research Center. I actually worked for his wife for a while on that project I told you about before, the Freshwater Inflows Group. She was with Houston Advanced Research Center as well. But I remember him talking about this in a class I took from him, and this is actually captured in the second edition of the Galveston Bay Estuary State of the Bay document that documented conditions at that time. I think that dated back to the early 2000s. He talks about in the late 1950s when he was in school, elementary school, and they took a tour out with the Port of Houston on their boat, which you can still do today, by the way. They still offer a really neat tour of the port facilities in upper Galveston Bay area. But he talked about his experience, and one of the things that really struck him was how toxic the air was, in terms of it burned his eyes, even, right? He described it as noxious. And so that really limited his class and his classmates' deck time. Actually being able to be out on the deck and not in the air-conditioned cabin. There's a lot of observations of that upper Bay Area, particularly in the Houston Ship Channel and lower San Jacinto River, describing the water quality and the fact that it was very black, and that there weren't a lot of living organisms in there, and it had a lot of volatilization of chemicals that were dumped into the river. Rivers at that time and prior to that were not only were they sources of drinking water, but ironically, they were also sinks for waste. There was a lot of direct effluent out into rivers and streams with the idea that, A, the water would dilute whatever the pollutant was and make it less dangerous, but also that it would carry it away. In fact, I remember, even in the 1980s, if you went out on Dickinson Bayou down in Galveston County, there were pipes going right out of houses along Dickinson Bayou that periodically you just see big slugs of water coming out of every time somebody was running the washing machine or flushing a toilet or taking a shower, right? Not going through any sewage treatment at all. And again, the understanding at that point, especially in the 1950s, just wasn't that strong. The science just really wasn't that targeted on that. And so consequently, we were doing a lot of things that just weren't good for not only the environment but for ourselves. And even in many populations, that still lingers today. There are still some areas around Houston where there's still issues with septic systems, for instance. And part of that has to do with demographics and poverty, but part of it has to do with just a lack of understanding. And so there's some legacy issues, and we may have the opportunity to unpack that just a little bit as we go forward. But when you look at the current day, I want to point out that there's been a lot of change since the early 1970s now into the 2020s. Some of them are good, some of them are not so good. I think one of the areas that is particularly concerning for me as not only as an aquatic toxicologist, but as an aquatic ecologist, is sea level rise. The Gulf Coast, specifically in the upper Texas coast, and this stretches all the way around the upper Gulf Coast past Louisiana, is suffering some of the highest sea level rise rates anywhere on Earth. The measurements at Pier 21 in Galveston, again, are globally among the highest. Part of that is because of true sea level rise, where you have water expansion because of warming, where you have inputs from glacial ice sheets melting and that water running off into the oceans. But part of it is related to ground subsidence. The Texas coast and Louisiana coast are largely sedimentary in nature, so there's not a lot of rock. There is a lot of water, however, embedded in that soil. In fact, many of our aquifers, the most surface of which is the Chakotay Aquifer, runs right under the surface, right under Galveston Island, and there are several others that stretch inland that run deeper, but these aquifers are not like aquifers you'll find in other parts of the state. Like if you go up to the Edwards Aquifer area in the San Antonio region, that aquifer is largely confined in solid limestone. So even though that aquifer is being impacted too by so many people drawing groundwater, but as it lowers, that's not causing significant impacts on the elevation of the ground, causing it to sink. But here along the coast, the water is actually embedded between individual soil particles. Those spaces are called interstitial spaces, so they're between each individual particle. So imagine my hands as two individual particles, and that space, let's see if I can get a good view of it here, by that white door, right? So that space between my hands, that would be an interstitial space. Well, when you pull water out of the ground, the water is pulled out of those interstitial spaces and it releases the hydraulic pressure that the water puts on those two particles. And so it allows them to come closer and closer together so they compact. When they compact, the ground on the surface sinks. So it's kind of like if you had a water balloon under the sand in a kid's sandbox, you suck the water out of that balloon, the sand on top of the water balloon is going to sink. It's the same kind of effect. So that causes some really significant issues. It's led to higher rates of erosion. It's led to significant losses of coastal wetlands, both on the Gulf Coast and up in the Galveston Bay area. So this is a fairly extreme example, but it's not an unusual example. Where you can see how large that tree is, and you can see the amount of soil that's dropped off of here. This is probably about as tall as I am, right? So about 6 feet. And I've seen areas that's higher than that. and you can have subsidence that moves back. So it'll continue, I'm sorry, erosion that'll continue to move back, and you might lose 4, 6, 8, or more feet every year further back into the adjoining property because of continued erosion and subsidence. So this is an area, unfortunately, that is not improving. And I don't know if it's gonna, I don't know anytime soon. I think this is very much tied to global climate change. But there are issues here on the coast that we can do that can improve this, certainly reducing our groundwater use. So there were big efforts made starting in the late 1980s through the formation of the Houston, Galveston, Brazoria area subsidence district that started to regulate groundwater withdrawal. That's why now so much of our municipal water, drinking water, is taken from our rivers, and the impoundments on those rivers is in order to reduce the amount of groundwater that's pulled out of the ground. Now, I recognize in rural areas, groundwater is still really the only practical source for groundwater. It's the only practical way to get water to the population, because moving water from the surface resources when you're in a very rural area, you might be the only person on several hundred acres. They're not going to pipe out to you. You would have to pay for that yourself, and for most people, that's just not practical. But now I can safely say in the 2020s, that is a minority compared to a majority that it would have been in the 1960s. So that's a good thing, and that certainly had some impact in terms of sea level rise in our area. But it's still a significant issue along the entire Gulf Coast. Okay. Some of the areas we have persistent problems that are improving, but we still have work to do, are areas like persistent organic pollutants and heavy metals. Oil and chemical spills, they are decreasing, and that's good. So if you look up here in this top left corner, you can see that the number of oil spills and the volume of those spills generally has been decreasing. And so that's a good thing. Now, in 2019, there was a fairly significant spill associated with a barge collision up in the San Jacinto River, and it released quite a bit of oil. But overall, that has the trend has been downward. So that's been a good thing. But we have a lot of legacy pollutants. Like I said, I mean, this area has been developing for well over 100 years, and there's a lot of opportunity for persistent chemicals, things that don't break down readily in nature. And a lot of these are anthropogenically produced, so they're synthetic, right? So things like polyaromatic hydrocarbons, PCBs, polychlorinated biphenyls, heavy metals like mercury, which are not synthetic, but they are released through activities that we do. So a lot of that has to do with the burning of coal. Lignite coal that is mined in Texas has a lot of sulfur and does have some mercury involved in it. So when you burn it, it gets out into the atmosphere, and what goes up comes down. So eventually it finds its way into the water, where bacteria can transform it into methylated mercury, which is very easily taken up by biologic organisms, especially fish, and can find its way all the way up the food web to us, right? So that's an issue. So these are things that are still problematic, but they are improving. I can tell you that as we move forward, we'll look at this a little bit more as we move forward, but we have seen significant improvements, in part because things like the Clean Water Act and the regulations around that have been in place now for nearly 50 years. That over time is allowing some of those things to break down. So things like DDT, for instance, which is another persistent organic. 30, 40 years ago, if you look for DDT in our environment, you would have found it pretty readily in the sediments. Now, what you tend to find, if you're going to find anything, is less so DDT and more so its primary breakdown product, which is DDE. So it's a slightly different shape. It's equally as toxic and has a pretty long lifespan in the environment. Its half-life, DDT, I think, is 50 and 75 years. DDE is about that same time frame. But what that suggests is that it is breaking down, right? So over time, those concentrations in the sediments and organisms are going to be lesser. So that's a good thing. Pesticides, we live in an area that has a lot of agricultural impacts. And again, as the science is continuing to improve, there's been a lot of effort to reduce the amount of pesticides. Markets play a big role in that. So choices you make in the market with your dollars have an impact on that. So if you're looking for things, that have less of those things in them, whether that's because you're concerned about your own health or you're concerned about the environment, those dollars count, right? They're votes. And so I've seen the market change a whole lot in the last 20 years. And as a consequence, a lot of our practices are much more sustainable today than they would have been. And this is a reflection. Now, one of the areas, so let me focus on one particular area that is particularly concerning to us in this area, is these persistent pollutants, both organics and inorganic pollutants, things like heavy metals. They can result from discharges to the air, to the soils, and to water. Things that end up in the air can end up in the soils and the water. Things that end up in the water can volatilize back to the air. They can sequester to soils and sediments. Things in the sediments can volatilize to the air, or they can leach out into water. So there's this huge connection between all of this. And consequently, they can move around. Also, the pollutants that I mentioned in the previous slide are not the only pollutants we have to be concerned about. There are a number of emerging contaminants. Pharmaceuticals have been an issue of concern, especially in very populated, densely populated areas for 25 years. When I was first developing an interest in toxicology and aquatic ecology, pharmaceuticals, we were just starting to pay attention to that stuff. It's like, why do we find things like Neurontin or carbamazepine, which is it's a anti-seizure medication. Things like estrogen, a whole variety of medications. You can find trace amounts of them in our watersheds. In some cases, at levels that they have an impact on the endemic wildlife, and over time through repeated or persistent exposures can have impacts on people. Right? So pharmaceuticals are one of those things that there's been a lot of study around, and as a result, that is having some impact in terms of water treatment, in terms of how those pharmaceuticals are managed. Microplastics is an area of emerging concern right now. I'm sure you've seen all kinds of things about not only plastics in the environment, but their breakdown products and their potential health impacts and environmental impacts. I have students on one of my studies now that are looking at microplastics, both in terms of the amount of sequestration that's occurring in sediments in our study areas, but also then identifying what those specific plastics are via infrared spectrophotometry. And the thing here is that those types of toxins, all of these things that we've talked about, can sequester to sediments and consequently can sequester to fish tissue and then to humans via the food web, right? So things can bioaccumulate in the smallest organisms in the sediments of water that are the base of the food web. And then they can biomagnify as they work their way up the food web. And so as a consequence of that, what I'm showing you in these two maps are areas that are impacted by these types of contaminant sequestration issues and resultant fish advisories through the Texas State Department of Health that recommend reducing or eliminating consumption of many types of fish in these areas because of the concentrated amount of chemicals that are of concern in these sediments that work their way up the food web. So this is a closer look at just the area up here in the Houston Ship Channel area, and you can see that the contaminants of concern here include things like, I'll put my laser point, things like dioxins, pesticides, organochlorine pesticides, PCBs, or polychlorinated biphenyls. And then there are other areas that are they recommend for women and children not eating essentially anything that fall in the families of catfish, spotted sea trout, or blue crab. And in some areas, especially above the Fred Hartman Bridge and Morgan's Point in here, not eating anything, right? And then even for those that are post childbearing age or adult men, consuming this to one meal a month, and they actually have target amounts of like 6 ounces a month, right? So we're talking about tiny little bits. And that should inform you how problematic that is because a lot of these things have multiple actions of toxicity in human systems. So in many instances, they're carcinogens, of course, but they also can cause birth defects. So they're teratogens. They might have impacts in terms of your nervous system, so they're neurotoxins. Many of them mimic hormones, which then can disrupt your endocrine system. That can have really big effects on people's ability to have children or disabilities in those children. So it's not something to take lightly, and you'll see these kind of issues not only in the Galveston Bay area, but if you look at heavily industrialized waterways anywhere in the world, even here in the U.S., you see these kinds of issues. Okay, so in class you would have seen a couple of clicker questions. So pollutants associated with Galveston Bay, can they be found in water, air, sediments, fish tissue, or all of those? Well, if you answered all of them, that's the correct answer because there's so much movement between those media, right? So you'll find oftentimes the same toxicant in all of those media and animal tissues. All right, so let me give you a specific case study associated with this. So I'm sure there are some of you who remember Hurricane Ike or have learned about Hurricane Ike in some of your classes. This was another pretty significant storm that has only been within the last 15 years or so. So it still has some real salient impacts today that are ongoing. So Hurricane Ike, when it came in as a Category 4 storm, and it traveled a pathway. So you're looking at an area of the San Jacinto River. So this is right off the upper portion of Galveston Bay where the San Jacinto River empties in there. So just east of Houston, right? Just east of Houston. So here's I-10 here. Here's the campus that I teach out primarily up here in Baytown. And so you can see this pathway went just east of Baytown, actually through part of Baytown, and just east of Houston. And the storm surge, right, here in this area where it was the darkest blues, was about 19 feet above average sea level, okay? 19 feet at the wave caps above average sea level. All right. And we're talking about an area that the average elevation ranges from sea level up to about 23 feet at the highest points. So we're talking about an average somewhere between that. And often it's a little bit lower because this is a wet area. There's Goose Creek runs through there. Cedar Bayou is over in that area. So it's low. There's a lot of low coastal wetlands, forested wetlands. So it's significant and a lot of infrastructure in this area. So again, this is part of Houston's biggest infrastructure complex that encompasses a good part of Baytown with the Exxon complex here. But I want to highlight a specific part of this watershed, and that's right where this red dot is here, where I'm circling it with my laser pointer, right? This area is what is a historic waste storage site for an old paper mill that used to be up the river here a little ways, up in the Highlands area. Now, again, this is part of a whole complex of facilities along the Houston Ship Channel here, right? So this area, a colleague of mine, Hanadi Rafai, is with she is with the Civil and Environmental Engineering program at the University of Houston main campus. She and her graduate students for many years have been studying dioxins in the upper part of the bay and its tributaries, and also bacteria. And actually, I think she was responsible for studying working on the TMDL and helping study the TMDL for bacteria in these watersheds. In any event, what's mapped out here are low-lying areas that would be impacted by a storm of this magnitude, right? So when you have a storm with storm surge of that level, these are areas that would be flooded and damaged as a result of that storm surge. Clear up into the ship channel quite some distance, all the way up to where the Port of Houston is, right? And some of these low-lying areas back here behind the channel as well. And so, in fact, that's what we saw. Bike, when it came in, it was moving a lot of sediment from the Gulf of Mexico. More than half of Galveston Bay's oyster reefs, for instance, were covered in sediment and have not recovered to the present day. It accelerated dramatically erosion along the shorelines because of the amount of water and wave fetch that was associated with it, had a direct impact on water quality for a long period afterwards. And there were significant releases of pollutants from damaged facilities in these areas, right? So this includes municipal waste treatment systems, industrial properties. There were over 180 industrial sites that were impacted, releasing everything from industrial chemicals to diesel oil to oil that then found its way out into the bay, sequestered to sediments, got up, has been taken up in living tissues, was discharged to the air because a lot of those things are volatile and will evaporate into the air. So, but I want to again focus on that site. So let me go back to this. So I want to focus on this site, this waste pit, and I want to describe it a little bit so you have a better understanding of what I'm talking about. So a waste pit is a storage site. Historically, there were a lot of paper mills along the San Jacinto and Trinity rivers. There's a lot of timber that was cut in East Texas. And so an easy way to transport it, of course, was down the rivers. You could actually literally float the logs. This still occurs across much of the western United States. And so they go to the mills. The mills would pull it out of the river. They would then mill it. It was ground, it was produced paper products, lumber products, all kinds of things. In the paper production component of it, and in some other materials, the paper was bleached, and the bleaching process creates these organic chemical complexes, families of chemicals that are hazardous, right? The chlorine in that bleaching process attaches those, and it forms these kind of organochlorine compounds. And so one of those things, one of those byproducts are dioxins, which are families of chemicals. And I'll talk about more of those in a minute. But so there were elements of this that were liquid waste, and there were elements that were solid waste. Historically, everything was just discharged to the river, and that's part of why my colleague and former instructor talked about his experience in the 1950s, because so many things were just discharged to the river. After a while, they started collecting the solid waste components, and those were disposed of in landfills of sorts, these pits. One particular pit associated with one particular landfill was located on the San Jacinto River in that island. So this was an island in the middle of the San Jacinto River there, right where the I-10 bridge crosses. And at that time, in the 1960s, it was quite a large island. Ground subsidence really, it was happening, but it wasn't really painfully obvious at that point. Things weren't moving enough to really create a lot of alarm. That didn't start to occur until the late 1960s and through the 70s and 80s, when things were literally sinking at really significant amounts, inches per year. So this island had some elevation to it, and it was primarily clay. A lot of our rivers have a lot of Lizzie and Beaumont clays. We're going to talk about that quite a bit over the course of the semester. And the state of the technology at that time for a lot of landfills was to line them with clay, because clay it has such small, the clay particles are so small, the interstitial spaces are so tiny that it doesn't allow water to flow very rapidly. Our coast has a lot of clays in it. That's why a lot of the inland areas flood so readily, is that when water falls from the sky, it doesn't percolate through the soil very easily. So we get a lot of standing water for some period of time until it either runs off or has an opportunity to soak down into the aquifers. So they had this pit on this island they dug out, and it had a lot of clay in it. So they were like, okay, it's clay lime, so we'll just go with that. So they started dumping this material in it, and then eventually the paper mill closed, the waste facility site closed, and this site was covered over, and then actually it was abandoned by the waste company. So McGinnis Waste was the company that owned it at the time. They were later bought out by Waste Management Association, which is important. We'll talk about that in a second. And I think the paper mill, I can't remember who owned the paper mill originally, but I think it was and subsequently bought out by Weyerhaeuser, maybe. I think. No, don't quote me on that. I think that's correct. In any event, this is also in a part of the river that not only has a lot of industrial facilities, but it also has a lot of fishing, and there's some boating that occurs in the area. And some of that is recreational, but a lot of it is actually referred to as subsistence fishing. So a lot of the embedded neighborhoods in these industrial areas are not high income earning demographics. They're often very low income earning demographics. And they also have um, uh, relatively meager educational attainment relative to the population generally. So high school or lower in many instances. And also, in some instances, there's a high proportion of ethnic minorities in many cases that are not primarily English speaking, where English is either a second language or not spoken at all. And so those populations oftentimes depend more on resources that they're not going to be getting at the supermarket, So fishing, for instance, is of cultural importance in some communities, Vietnamese communities in particular, but Hispanic and African American communities, and even Caucasian communities in these areas oftentimes fish these areas as part of their grocery budget, right? With a lack of understanding of the potential issues that we saw from the fishing closures. Okay, so you can see what this pit would have looked like in the 1960s. And they literally pumped this material in as a slurry and then allowed the solid components to settle out, and the water would literally run over the berm back into the river, right? So it was, again, this thing come a long way, thank heavens. The chemical compounds in this waste included heavy metals, it included things like PCBs, but a whole variety of other things, including dioxins. And again, a lot of these are families of chemicals, so it's not one specific chemical. Let me not blend those words. One specific compound. It is a range of compounds all belonging to a similar family. And again, they have a lot of toxic actions like we talked about previously. So during Hurricane Ike, there had been concerns previously because subsidence became such an issue through the 70s and 80s. And this area that was this island had really sunk. The river had really opened up significantly. And so there were some concerns, but there wasn't really an understanding. A lot of the information around that waste pit had been kind of lost over time. And, people just weren't paying attention to it. But during Hurricane Ike, and actually just prior to Hurricane Ike, the condition became really obvious. Actually, let me go back a slide. Let me show you something. 2 slides. So this picture in 2005, so just prior to Hurricane Ike, this picture, I remember this going around. I got it through a connection with Parks and Wildlife, but I know it was making the circuit across a number of regulatory agencies. And what I want you to notice here is up on the surface, there's this light tan. This is sandy clay, right? But right here, you see the color of the sludge is gray. This is actually that waste material that has a very high proportion of dioxins specifically. There are also PCBs and some heavy metals, but dioxins specifically. And it it was discovered by somebody that was actually standing here fishing on it, noticed that it looked weird, it smelled weird, what's going on here. And what had happened was just through regular storm activity over the preceding decades, really, it had continued to erode until it actually got into the waste pit proper. And so this waste was leaching out into the river and working its way downstream. Well, at the same time, the Texas Department of Health Services, in cooperation with Parks and Wildlife and the Texas Commission on Environmental Quality, EPA, these other agencies, um, they were regularly routinely testing fish tissues, and they were finding spikes in dioxin in fish tissues that really didn't make sense because prior to that, as we talked about, there had been a lot of scrutiny on releases into the ship channel through the 80s, 90s, and 2000s, early 2000s. And so the amount of dioxins in the environment and consequently the amount that was being found in fish tissue had been decreasing. Well, okay. So it didn't make sense, right? Until this was reported. And then they started to link these things together. And then there was a lot of concern about that again because of these toxic chemicals. So, long story short, in very short order, the site was cordoned off. They put fresh cover over it. They actually put riprap around the edge of it. You can see a little bit of that here along the edge. So they put riprap along it to kind of protect the toe of that slope, among other steps they took to try and protect it until they could figure out what to do with it. Well, then Hurricane Ike came along and it moved a lot of that riprap. It created a significant amount of erosion in this area, and it was really a major concern. Now, when this was reported to EPA, as I said, the site was closed, and actually it was listed under the under CERCLA that we had talked about before. And under CERCLA, there's a program called the Superfund program, and what the Superfund program is when it identifies a highly contaminated site. The idea behind Superfund is to put the responsibility of cleanup of that site to normal ambient conditions back on the responsible parties. Okay. And one of the interesting elements of the Superfund program is that when, as in this case, the responsible parties were no longer actually in business, they were no longer, those corporations had long been dissolved or were absorbed into other entities. The entities that became responsible for those sites then bear that responsibility. So, part of the work I've done over the course of my career is due diligence work, going out and doing phase one type site assessments, really just to look for, is there a potential problem here that might cause liability to somebody on this property that we need to be aware of and do some cleanup ahead of time or whatever it is, right? So here, they identified Waste Management Association, and I want to say it's Weyerhaeuser. Please don't quote me on that. I can't remember off the top of my head. As these responsible parties. And so what that means is that these parties are either responsible for cleaning this material up, or they have to reimburse the federal agencies who would do that for them, right? And so as you can imagine, these are typically very contentious, very litigious, and it takes a while, it can take a long time. There's actually a really happy story with this, and I will direct you, if you're so inclined, to learn more about this because it's a really interesting aspect of the Galveston Bay system. In any event, one of the nonprofits that is an advocacy association that has been working in kind of lockstep with the agencies to try and get this site cleaned up and push this through the Superfund process as quickly as possible in order to get the site cleaned up, took an interest in this, and they actually did a dye study or commissioned a dye study. And so this is kind of an interesting thing. So a dye study, this is where you take packets of dye and you put them in the water, the packet dissolves, and then it allows this color to move through the water column and out into the system to determine how water is moving. And so if you had a contaminant that was moving through that system, where is it likely to land, right? And how quickly is that going to occur, and how persistent is it going to be? So they drop this, they drop these packets, and then they track this through here. So again, remember, this site is here, right, where my laser pointer is. And what they found was the dye moved very rapidly. So in a matter of 2 hours, it had moved considerably downstream past Kirby Morgan, where there's all those barge facilities there. And actually, it started to back up into this back channel here a little bit. But it was moving along, and you can get a sense of the concentrations based on the colors. And so after 6 hours, here you can see it's moved, and the concentration is very high back in this area. So again, this is a channel around this island here. Here you can see, yeah, it's not as strong, but it's moving pretty rapidly. Here's 12 hours later. You can see it's moved. This is almost down to the upper part of the bay itself and out into the bay. But the interesting thing I want to point out here is how it's actually backing up into the Houston Ship Channel. Remember, these are tidal waterways. And so, with the tides, you have water moving out because it's a river system, but then also the tides can actually back that water back up. And in fact, that's what they saw happening here. So you had dye that was actually working its way upstream in the Houston Ship Channel. So once the release stopped, you can see it pretty quickly up in the river itself, kind of moved out from where the Superfund site is up here, right? You don't actually see it hardly at all. You can see it persisting in some of these areas where it had a fairly significant residence time in there. The longer it's there, the more likely it is to sequester to sediments or become a more permanent part of that particular environment. And remember, some of these chemicals have half-lives that are 50 years or so in these areas where it can stay present for long periods of time, chemical reactions take time. Again, it's more easily sequestered into the sediments, and that means that it's going to reside there, and there's more opportunity for exposure, repeated exposures, right? Okay, so and I want to draw your attention to some of these little embayments. So these are areas that subsided, and they formed these bays off of the river proper. And you can see that there is some residence occurring back in there over time. Same thing down here where water's not moving very quickly, and so it's sticking around there for some period of time. And then eventually it moves out. But here again, so this is Burnett Bay, kind of close to where the I-10 is and the ferry there, Lynchburg Ferry is right there. And in fact, when I worked for the nonprofit, we actually had a grant to do some habitat restoration in this area. And as part of that restoration, one of the things I did was I helped shepherd some of the toxicology there because one of the concerns was that this area it kind of acts like a catcher's mitt there on the Houston Ship Channel. And my concern was that if there were silty or clay areas in there, those tend to sorb those chemicals more readily and hold on to them longer. So we wanted to verify that we weren't creating a public nuisance in there by putting plants that were going to attract fish and attract fishermen and people and that sort of stuff. Now, in fact, the cores we found when the work was done, we did find some toxins in there. They, again, were primarily associated with the clay material that was going to be covered by the project. So the project did proceed, but it does highlight that that when we did that project was a few years after Ike, and there was still resident levels of chemicals in some of these areas. So when you have these kind of releases where there are persistent chemicals that are involved, they can have long-lasting impacts that have to be part of that public discourse and part of our public safety mantra to be able to deal with. So what did we learn from all this? Well, we know that sea level rise and elevated water temperature certainly are having an impact on storm intensity. And that means that there's more vulnerability in these areas because sea level rise, kind of raises the ambient level. It means that the same storm surge in 2020, because the base sea level is higher, is likely to have a greater impact further inland than a similar storm surge 25 years ago, right? And so a lot of our industrial facilities and residential areas and the Bay proper are more susceptible to impacts as a result. Coastal habitats are very stressed by changes in temperature and rainfall, and these anthropogenic impacts that makes them more than fragile and susceptible to additional impacts, especially those related to climate change. And one of the major problems here is that our coastal economy is very dependent on the environment, right? The ship channel is where it is because of the nature of the protection that that area facilitates, but also its ready access to the Gulf of Mexico, and also fisheries, right? Are these are extremely important industries. Commercial and recreational fishing in the Galveston Bay area are substantial to the tune of hundreds of millions of dollars annually just in the Galveston Bay area, right? From commercial and recreational fishing. So things that impact our ability to harvest and safely consume those fish has a real impact on our bottom line in this area. So even if you're not concerned about the natural impacts, the community, biologic community impacts, the economic impacts are significant in and of themselves. So, okay, let's spend just a couple minutes and talk a little bit about Galveston Bay's geology, because that has importance in terms of things like these anthropogenic impacts, but also how these biologic communities occur and where they occur. So, the geology of the bay, as we've touched on before, is very interesting to me. You know, the very shape of the bay itself is a result of the meandering of these rivers, especially the Brazos River, the sedimentary nature of the soils, the sediment regimes along the coast itself. These have had a real shaping feature, not only of the whole Texas coast, but Galveston Bay specifically. Um, there are everything from deposits that date back to the Pleistocene area, river deposits like we've talked about. There are barrier ridges that have formed because of these sediment migrations up and down the coast. And that has formed these Chenier plains. And Chenier plains in and of themselves are kind of an interesting geologic formation. So you get these essentially these ridges, and these were beach dunes essentially, right? This is these are high points that then allow material to depose in between them. So we're going to talk about this later when we talk about dune habitats, but these ridges, these dunes, they kind of pile up in front of each other, barring some major erosional event. They have a tendency to build outwards, and then that forms these Chenier ridges, and then you get a coastal plain that settles in between them as a result of sediment deposition. So Chenier, by the way, means oak in French, and the plain itself and the wetlands that form in those plains are primarily freshwater. They're not tidal, so oftentimes they're captive in those particular areas. And we're going to look at that a little more as we move forward. And you see those up and down the Texas coast, right? And well, actually, not only the Texas coast, but the Louisiana coast is what you're seeing in this particular graphic. So one of the areas that they're really obvious and evident is in Galveston, you know, right where the campus is situated. You've got this very thing occurring here, and you can see it when you look at an aerial of Galveston Island. So here we've got a Google image here or a satellite image, and so here you can see these long lines going from the east end of the island to the west end of the island, right? And they extend throughout this entire snap right here. Now they move a little bit. It's not consistent. They're not all identically parallel. And that talks, you know, that speaks to the changing environment. Again, water regimes in different years, sediment regimes changing over time, that kind of thing. You can see these. So Let's focus in on a little area right here. And I want you to pay attention to these long linear lines right in this area, kind of in the northeast corner of this red box. And you'll see a little bit of down here as well. So if we highlight that area and zoom in on it, what you'll see here are, let me move out towards the beach. So here's the beachfront, right? And you can see back here these different colorations. Some are darker, some are lighter. These are referred to as dune swales. And so the darker areas are the swales, the deposits, the low areas. Again, we're going to talk about this in more depth if you'll pardon me. And so you've got the high dunes and the swales between, right? So you've got these kind of inundations. Well, the lighter parts are the higher areas and the darker parts are the lower areas that tend to pond with water. You can see that up here, right? So in some instances, these go back thousands and thousands of years as the beach had moved out, 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 and out, right? So another swale, I'm sorry, another dune in front of another dune in front of another dune. Now, in some instances, like in here, these swales have fresh water that has no connection to either the Gulf or the bay. And so the only connection to any other water they have is through the ground into those surface aquifers like the Chakotay Aquifer. So they're important for recharge for that area. They're also really important because we happen to be on, for one example, we happen to be on a major migratory bird flyway. Actually, we are on a superhighway flyway. In that there are 3 flyways covering all of North America from the far west coast to the far east coast that come down through Canada, then into the United States, and they all kind of come together over the Gulf Coast. And they all go over the Texas coast and down through Mexico, and then they split out again when they get into South America. Well, so this happens to be really important stopover habitat for those birds. That can include everything from different types of hawks like peregrine falcons and osprey to colonial water birds like sandhill cranes. That can include waterfowl, all different kinds of ducks, small songbirds. So all of these different things, they utilize these habitats as a stopover, kind of the Holiday Inn Express for wildlife, right? And it's because they have these freshwater resources that are not really very prevalent west of us. And east of us, it's mostly Gulf of Mexico. So there are some birds that fly across the Gulf of Mexico, seabirds in particular, that will make their migration and they'll just go right across the Gulf. But most are actually utilizing these habitats. These are also important for freshwater, for agriculture, and that during those historically as well. Now, what I want to point out here is this is the Spanish Grant subdivision right here. And what you can't see, it's under this box, there's actually a canal that's dug out into West Bay. But you can see the canals in the subdivision themselves actually follow the swales between these historic dune ridges. Now, the backside of Galveston has also been an area of some subsidence. So this area has changed as the ground has sunk. This is Eckerd Bayou, so you'd recognize this as Settegast Road. This area was slated for another big new development. Actually, fortunately, several agencies and a local series of local nonprofits, including the Galveston Bay Foundation, and most importantly, the Artist Boat, were able to secure this land. And now the Artist Boat owns and manages it as a wildlife preserve, part of that coastal prairie complex along the backside of Galveston Island. There's a really great kayak launch there. Maybe I'll talk about that more because there's some great areas to kayak up in there. In any event, what I want to point out is that because of Eckerd Bayou opening up a little bit and eroding, there have been connections to these swales. Some of these have been dug out, and consequently, these are no longer fresh water because they have developed a connection to salt water. And this is one of the ways that important freshwater wetlands that we're going to talk about later in the semester often become something different, is through some sort of conversion. The canals really have very little wildlife value at all anymore. This area still has very significant wildlife value, but it's different than what it historically would have been by the formation of these. So we're going to pick up with that next time, and we'll continue talking about Galveston Bay and its structure and history. So thank you for your patience, and I hope this is all interesting. Please feel free to reach out to me if you have any questions. You know how to get me. And I'm very pleased to talk to you. So let me know, and I will look forward to seeing you next time.